Okay, so today we're going to talk about is absolute value equations and inequalities. You can get most of this information from your foldable. So your guide notes is two-sided. So let's just kind of look for this. First thing you want to remember is when you're doing this, you want to treat the absolute value as if it were like a big old X. Now, when you think about this, this is the distance from zero. So you're going to say that something is something's distance from zero is 5. So I have two equations. I can have two options. I have positive 5 and I have negative 5. And then when I'm doing this, I'm just going to say m plus 8 equals 5 and m plus 8 equals negative 5. So then I have two really basic, easy breezy equations. So I subtract 8 here and I subtract 8 here and I get m is equal to negative 3. And then over here I get a minus 8 and a minus 8. And I get m is equal to a negative 13. So those are my two answers. Okay. Looking at another one, this one you have y plus 17 absolute value minus 25 equals negative 10. What you want to do is you want to make sure that you isolate the absolute value. So the first thing I'm going to do is add 25. So I add 25, so now I got the absolute value of y plus 17 is equal to negative 15, or excuse me, positive 15. And then now again, I go back and I say, well, then what's my absolute value? What's my distance from zero? It's either going to be positive 15 or it is at negative 15. And so I have the y plus 17 in two locations, here and here. So then what I do here is I go ahead and subtract 17. So I get y is negative 2, and also I subtract 17 here, and I subtract 17 here, and I get y is negative 32. All right, seems pretty easy enough. Let's look at a third example. Here are a couple of, like, two more examples. So what are the solutions of t minus 8 equals negative, or equals absolute value of t minus 7 equals 8? I'm going to set it up as t minus 7 equals 8 or t minus 7 equals negative 8, and I'm just going to go ahead and solve. Add 7 here, add 7 here. I guess that would be t is 15. And I add 7 here, and I add 7 here, and I get t is negative 1. Those are my two possible answers. Now on this one's unique because this is the absolute value of a number is negative 3. This one is no solution. No way, Jose. You cannot get that. Not going to happen. Not ever. Nada, nada, enchilada. Now, let's step this up a little bit and look at absolute value inequalities. Okay, this is the second page of your guided notes. On absolute value inequalities, you have two things you have to look at. When you have the absolute value of something is less than 5, that's your compound inequality, and when you have your absolute value is greater than 5, that is your compound inequality, or. So let's take a look at these two, this example. So what are the solutions of the absolute value of 2n minus 3 is less than or equal to 9? Well, this guy, this matches this. So I'm going to use that. So I'm going to set it up as 2n minus 3 is less than or equal to 9, and 2n minus 3 is greater than or equal to negative 9. And I'm going to go ahead and solve this. I'm going to add 3 here. All right, so then I get 2n is less than or equal to 12, and then I'm going to divide both sides by 2. I get n is less than or equal to 6. And here I add 3. So here I get 2n is greater than or equal to negative 6. And then I divide by 2. 2n is greater than or equal to negative 3. Now when you're doing this, you can set this up. Your graph will look like this. Here is your negative 3. You have a solid circle, and it's going to go this way. And then here is your positive 6. You have a solid circle, and it's going to go this way. So there's your graph of those two problem, or that one problem. You get 2 in 1. It's buy one, get one free. How about this one? V is absolute value of V minus 3 is greater than or equal to 4. Now this one fits the OR scenario. So I'm going to go V minus 3 is greater than or equal to 4, or v minus 3 is less than or equal to negative 4. That's just a little rule. We talked about this in your foilables. So go ahead and add 3 to both sides, and you get v is greater than or equal to 7 here. Or you have add 3 here and add 3 here, and you get v is less than or equal to negative 1. Now if we were to graph this, okay, I'm going to see that negative 1 is going to go right here, and I got a solid circle, and I go to the left. And then here I put a 7 here, and I got a solid circle, and I go to the right, just like our compound inequalities. See, I told you this is easy. Easy breezy, cover girl. All right, check it out. This one, which one are we going to use? Are we going to use the, is this, it's less than or equal to 7, so are we using the or are we using the and compound inequality stuff? That's right, we're using the and stuff. So when we set this up, we're just going to go n plus 1 is less than or equal to 7, and n plus 1 is greater than or equal to negative 7. So now this is really easy. Just subtract 1 and subtract 1. You get n is less than or equal to 6. And then here you subtract 1, you subtract 1, you get n is greater than or equal to negative 8. So when you set this up, your graph, you got negative 8 right here. Put a solid dot right there. You got positive 6 right here. Put a solid dot, bam, right in between each one of them. Very simple. Hopefully that makes sense. You know, we're almost done with this chapter. We got one more section. If you don't understand what's going on, pause it, watch it again, and may the force be with you. Bye for now.